Hello everyone, welcome to the BYJU'S Exam Prep, the most comprehensive app for all exams. First of all, let me know that sound quality, picture quality, everything is fine. Yes, please. Now, in this session, we are going to discuss BJT and FET, biasing and stabilization, right? It is the second session on analog circuit, okay? And in first session, already we have discussed diodes and its application. Some questions on clipper, some questions on clamper, right? Now, in this session, we will discuss biasing and stabilization of BJT and FET. Let me know that sound quality, picture quality, everything is fine. Yes, please. I think everything is fine now. Now, everyone, please subscribe our channel, like the session and share the link of this session. Okay. Now, BJT, biasing and stabilization. This topic is important for all competitive exams, especially for what GATE 2023. Okay. And in this session, this is a part of what GATE Champion series. We will discuss around 500 questions, right? And it is just like what live workbook. Okay. Number of questions. We will include numerical answer type question. We will include MCQs. That is multiple choice questions, and we will include what? MSQ, that is multiple select questions, right? And we will try to cover each and every topic, okay, so that you will get the idea about all the topics, okay, with number of methods, method 1, method 2 and method 3. Now, in a description box, if you want the PDF notes, to please go through the description box. Now, in this session, I will cover questions on MOSFET because it is a very important topic. It is in syllabus. JFET is not in the syllabus of what GATE exam. We are having the MOSFET, metal oxide semiconductor field effect transistor. So, biasing and stabilization means we will solve some questions on MOSFET. Then we will solve some questions on what? BJT. And we will solve questions also on what? Current mirror circuit. Current mirror circuit. You will get the idea about what is the difference between the fixed bias and self bias circuit, right? We will solve some numericals on that. And what is the transistor biasing? One numerical on that. Okay. Again, we will solve one question on what? Darlington pair. That is common collector followed by common collector, numerical. Then one question on what? Common emitter, and we will solve this question, and we will include what? All type of question. Numerical answer type, MCQs, multiple choice question and MSQs. Okay. Then let me know that sound quality, picture quality, everything is fine. Yes, please. First of all, inform me. Everyone. 1 minute, give me 1 minute. Okay, guys. Now, first, this is my introduction. Myself, Sanjay Rathi. And I am having around 21 plus years of teaching experience in the field of competitive exams like ESE, GATE and PSU. And these are my ranks: AIR 16 in ESE 2005 and AIR 21 in ESE 2008. And I have mentored more than 1 lakh students for these competitive exams. Now guys, this is very important information for you. Free workshop, how to start preparation for GATE 2024. Right? And that is live on 10th September at 8 PM. Please note this time, by Abhinav Negi sir. Okay. Now, first question on your screen. What is the answer for this question, everyone? What is the answer for this question? Right. Tell me, what is the answer for this question? Which action plays a significant role in enhancing the conductivity of channel by inducing the free electron, especially in enhancement mode of the N-channel MOSFET? Enhancement mode of the N-channel MOSFET. What is the answer for this particular question, everyone? 1 minute. Ravi Shankar, very good evening. What is the answer for this particular question? Is it audible? Okay. Now, which action plays a significant role in enhancing the conductivity? Definitely that is what? Capacitor action. In MOSFET, we are having the capacitive action. Okay. That is the right answer. Okay. Now, second one. Tell me. That is the basic question. Now, 1 marks question. Yes, your answer is correct. Second question. Consider the circuit shown in the figure. The transistor parameters are VTN is equal to 0.4 volt and Kn is equal to 100 microampere per volt square. The transistor width to length ratio, that is called W by L. It is also called aspect ratio. When VDS is 1.6 volt is, right? That is based on what? Biasing of MOSFET. And everyone tell me, watch this connection and tell me the transistor, this MOSFET is in which region? Triode region, cutoff region, or saturation region? That is called biasing. So by simply watching this diagram, first of all, we have to decide whether the MOSFET is in triode, cutoff, or what? Saturation. Once we have the idea about the transistor, then we can solve. We can find the value of the current here. This is the drain current. What is the gate current? Always remember the gate current is 0 because this resistance is almost infinite. The same current will pass through this IDS. Okay. What is given here? VDS is only given 1.6 volt. VDS is given as 1.6 volt. Now, remember that when a drain is connected to gate, always remember, when the drain is connected to gate, means VD is equal to VG. When VD is equal to VG, we can directly say VDS is equal to what? VGS. Both are equal. Once the VDS is equal to VGS, means 100% sure VDS is greater than what? VGS minus VT. VGS is greater than VGS minus VT. What is the VGS minus VT? VT is the threshold voltage. If this condition is satisfied, means definitely the MOSFET is in saturation. So this MOSFET is in what? Saturation. Now when MOSFET is in saturation and we have the value of the VDS 1.6, that is also the value of the VGS 1.6 volt. Now if this voltage is 1.6 volt, what is the voltage at this point? 3.3 minus 1.6. VDD is given as 3.3 minus 1.6. You can find the value of the voltage at this point. So what is the 3.3 minus 1.6? This is the voltage at this point. That is nothing but 1.7 volt. 1.7 is the voltage at this point. Divided by 10, it will give you the value of what? IDS. It will give you the value of IDS. So very good evening everyone. Yes, please tell me, Nema and Pankaj, right? Tell me what is the value of the IDS. So 1.7 divided by 10, that is nothing but 0.17 milliampere. Milliampere. You can also convert this 100 microampere into milliampere, 0.1 milliampere per volt square. This is the value of the Kn. Okay. Now, how to solve this question then? Once you know that it is in saturation, what is the formula for the saturation? Half of K and S W by L VGS minus VT the whole square. What is the value of IDS? 0.17 milliampere. Already we have calculated. 1 by 2. What is the value of the K and S? 0.1 milliampere per volt square. This is the value of the K and S. Now, VGA, W by L, we have to calculate the W by L. VGS is 1.6 volt. That is equal to what? VDS. VDS is given in the question. Now, VTN is given as 0.4 volt. Now, please everyone, by using this formula, calculate the value of the W by L. It will become 2 into 0.17 divided by 0.1 into 1.2 square. And you will get the aspect ratio. Very, very simple question on what? MOSFET, but logical question. Once the drain is connected to what gate, it will be in what saturation? No need to check. It will be in saturation. 3.3, and that is the value. Okay. What is the answer, guys? Sir, आपके EDC and analog के notes कहाँ? On my Telegram channel, please join my Telegram channel. That is already I have sent you the link. That is Electronics by Sanjay Rathi. Please join that channel. And everyone, please share the link of this session. We are going to discuss what number of questions. That is the first one. What is Ravi? 0.42. No, it is very low. You are giving very low value. I think after calculation you will get the 2.36 value. Please check that your calculation. In a MOSFET W, normally W, the width W is what? Greater than what? L. W by L, aspect ratio. Aspect ratio should be greater than what? 1. Otherwise it will reduce the current. Width is high always. Now, that is about the second, and answer will be what? B, 2.36. You can calculate it and check it. Okay. Now, next one, you have to square it. 1.2 square, that is the 2 into 0.7, and that is what? 0.1. Okay. Now, yes, are you getting this answer, everyone? You are getting this answer? Yes, 2.36. Right. Now, next one. Enhancement type N channel, basically termed as normally off MOSFET. Normally off MOSFET works only with. Which MOSFET is known as normally off MOSFET? E MOSFET or D MOSFET, everyone? Which MOSFET is known as normally off MOSFET? This is the MOSFET. Here we are connecting the VGS. It may be positive or it may be negative. It is a P-type substrate. That is the drain terminal and that is the source terminal. Okay, this is the SiO2 layer. And this one is the metal. This is the metal. And this is the semiconductor. Metal oxide semiconductor field effect transistor, MOSFET. Which answer is correct? Enhancement type N channel. This is the N channel. Normally off. Normally off means initially there is no channel in between. It acts as what? Just like what? Two diodes connected back to back. And therefore, there will be no current from drain to source. It is called normally off transistor. But when we want to increase the conductivity, we have to attract the electron in this portion. Electron is a negatively charged. If you want to attract the electron in this region, then what should be the value of VGS? We have to apply the large positive gate voltage. When we are giving the large positive gate voltage, it will attract the electron. So which answer is correct? Large positive gate voltage. A is the option. When we are giving the large positive voltage, it will attract electron and the conductivity of channel will increase. That is the answer. And then we are connecting here voltage. It may be small or it may be large. Then the current will flow from drain to source. But before that, we have to induce the channel. So that is the answer is what? A. That is the diagram of what? MOSFET. Enhancement type MOSFET. Next question. Now, this is the question on BJT. Everyone, what is the answer for B? First of all, we are solving the MCQ, multiple select question. And then, everyone, please share the link of this session. Okay, and like the session. First of all, like the session and subscribe our channel. And it is a part of what? GATE Champion series. We are going to solve around 500 questions from various subjects. It is just like what? Live workbook. Try to solve all this question. This is a very, very important one. Calculate the voltage VI. This is the VI. This is the VI. In the figure, we have to calculate the VI in the figure. Given beta, only 30. And Q point is exactly in the middle of the load line. And it is a silicon BJT. If nothing is given, you can assume silicon BJT. For silicon, why we are assuming silicon BJT? For silicon BJT, what is the value of the VBE? The value of the VB, it will be given in the question. Otherwise, by default, you can take this value, 0.7 volt. Calculate the voltage VI. We have to calculate the voltage at this point. What will be the voltage? This is the minus 12 volt battery is connected here. This is the ground and that is the diagram. Okay. First of all, read the question carefully. Q point is exactly in the middle of the load line. Everyone try to solve this question and give me the answer in comments box. Yes, please. Now, when it is asked Q point is exactly in the middle. Middle means the voltage at this point VC, it will become VCC by 2. And what is the VCC? 12. And therefore VCE will become 6. Once you know the value of VCE, you can calculate the IC. Once you know the value of the IC, you can calculate the IB because IC is equal to beta IB. And once you know the value of the IB, what is the IB? Let this current is I1 and this current is I2. So what is the IB? I1 minus I2. From that you can find the value of VI. Remember this voltage is VBE. VBE is nothing but 0.7 and this point is connected to a ground. This is with respect to ground. What is the value of the base voltage? Base voltage is nothing but VBE. So that is the hint and everyone try to solve this question. Now, in this question, always remember once the emitter is connected to ground, then you can say the VBE is equal to VB minus VE. That is nothing but VB. Why? Because emitter voltage is 0. Emitter voltage is 0. Second thing, similarly, VCE. VC minus VE, that is nothing but VC. The voltage at this point, it is called VC. Now, this voltage is what? 12 volt. 6 volt because it is in the middle of the Q point. And that's why this voltage is also 6 volt. IB. This voltage is 0.7 volt VBE, and VBE is nothing but VB. That's why the voltage at this point is also 0.7 volt. Now I1, and that is the I2. First of all, find the value of the IC. IC will become 12 minus 6 divided by 2.2. That is nothing but 6 divided by 2.2. Okay, first of all, you can write 6 divided by 2.2. This is the value of what? IC. Then you have the idea IC is equal to beta IB. So what is the IB is equal to? IC upon beta. Then 6 divided by 2.2 divided by 30. What is the value of the beta? That is nothing but 30. So this will become 5, and you can multiply it and you can get the value. You can use your calculator also. 11. That is nothing but 1 by 11 milliampere. Please check my calculation. Yes. This is the 1 by 11 milliampere. This is the value of IB. Now what is the IB? I1 minus I2. From the diagram, IB is equal to I1 minus I2. This is 1 by 11 is equal to, what is the I1 here? This voltage is 0.7 volt. So I1, I2. I1 will become VI minus 0.7 divided by 15. VI minus 0.7 divided by 15 minus, what is the I2? 0.7 minus of minus 12. It will become plus 12 upon 100. Everything is over. Find the value of VI from this calculation. Very, very easy. What will be the answer? What will be the answer for this question? Yes, please. So it will become 1 divided by 11 minus, that will become plus 12.7 divided by 100, 0.127 into 15 plus 0.7. You will get the 3.96, nearly equal to 3.96. What is the, which answer is correct? 3.96 or 3.97? C is the answer for this one. It will be of 2 marks, right? It will be of 2 marks. Simply, no need to apply the Thevenin's or theorem and so on. Simply you can say that is the I1, this is the I2. Remember that when it is one terminal is 0, VB is nothing but VB, VCE is nothing but VC. Get the value of IC, IB, and then you can find the value of what? VI. Okay then. That is a very, very important question. I think it is easy. If you have any doubt, then you can. Sir, IB say 12.7 divided by 100K. Nidhi Misra, where is the 12.7? 12.7 divided by, no, we can't say. That is the wrong concept. No, because what is the IB? One current will flow like this, one current here, and what is the IB? The difference of the I1 and I2. You are saying that the same IB is flowing through the 100 kilo ohm. That is wrong concept. One I1 here, I2 here, and then IB is the difference. I1 minus I2. Okay. I think that is clear to you. Okay then. Now, next question. Calculation. Please try to avoid the calculation mistake also. 3.97 volt. Okay. Wow. This is the MSQ. Multiple choice question. We have solved the 4 MCQs. Now the MSQ. What is the MSQ, everyone? Try to give me the answer. In the given circuit, if VCC is equal to 10 volt and VBB is equal to 5 volt. Where is the VCC? This is the 10 volt. And VBB is given as 5 volt. It is mentioned in the question. Beta is 100. VBE is a 0.7 volt. Then for IC is equal to 10 milliampere. Here we are having the IC. And VC is equal to 5 volt. Wow, everything is given. Tell me which answers are correct. Which answers are correct? Theory plus numerical. That is the combination of theory and what numerical. This type of MSQ we can expect in GATE 2023. Okay. Tell me which answer is correct. Then if you want to solve this question, first of all, read all the options carefully. And give me the answer. Yes, please. Now, if this VCE is given as 5 volt, 5 volt. This is given as 0.7 volt. This is 5 volt, this is the 10 volt. And IC is given as what? 10 milliampere. Everything is given here. What is the equation? What is the IC is equal to? VCC minus VCE upon RC. Now you can find the RC is equal to VCC minus VCE upon IC. And that is nothing but 10 minus 5 divided by 10. That is 0.5 kilo ohm. 0.5 kilo ohm. What about the first option? The value of the resistance RC is 0.5 kilo ohm. That is right. Okay, this is right. The value of the resistance RB. Now, if the beta is given, IC is given, you can find the base current. And what is the value of the VB? 0.7. From this, you can write IB is equal to 5 minus 0.7 divided by RB. We have to calculate the RB. And what is the IB? IC by beta. What is the IC? 10 milliampere. What is the beta? 100. It will become 0.1. So what is the value of RB? 4.3 divided by 0.1 means what? 43 kilo ohm. 43 kilo ohm. What about the next answer? This is also right. Okay. Now, that why it is given very simple numerical so that student will get the confidence. But it is a MSQ. It is a partial answer. Everyone tell me what about the third statement? How the VC is 5 volt? Ravi Shankar, it is given in the question. 10 milliampere and VC is 5 volt. Read question carefully before solving the question. Always remember. So what is the VCE is given as 5 volt, IC is given as 10 milliampere, everything is given in this question. And that's why it seems that it is a very easy question, but actually it is a MSQ. Tell me, now what is the answer? If 100 ohm emitter resistance is added, suppose if I am adding 100 ohm emitter resistance here, when RE is connected here, then the circuit will become self-biased circuit. That is right statement or wrong statement? Yes. If we are having one resistor here between emitter and ground, RE, it will provide you the self-biasing. Because of this RE, there will be the negative feedback and circuit will be what? Stable. And that's why this is the right statement. Now, for the given circuit means when the RE is not connected here. For the given circuit, the Q point is stable. Right or wrong, Akanksha? You are saying that right. But my dear friend, for the given circuit, if the RE is not mentioned in the circuit, this circuit is called fixed bias circuit. Fixed biased circuit. When this is a fixed bias circuit, when there is no RE, no negative feedback. No negative feedback. What will be the stability factor S? 1 plus beta. Stability factor for this diagram will become 1 plus beta in circuit. The Q point is highly unstable. And that's why this statement is wrong. Tell me which answer is correct. A, B and what? C only. Okay guys, now you are getting what is the when we are going to solve the MSQ. No doubt the first two portions are very easy. But after that, if you are not having the command over the theory, you are not able to give the answer for this question. Okay, A, B, C is the right answer for this question. Next one. It is not a typical question. Very simple. You have to get the idea about fixed bias circuit and self bias circuit. Okay. Next one. Now that is the question on NMOS transistor. NMOS transistor. Right? Or remember that in a GATE exam, they will shuffle the 1 marks question with 2 marks question. Right? Before the 2022, we are having the, first of all, we are having the 1 marks question, and after that, they will ask the 2 mark question. But now these days, they are shuffling 1 marks question, then 2 marks question, third question may be the 2 marks, it may be numerical answer type, it may be numeric NET type, it may be what MSQ. Okay, randomly. So you have to set your mind accordingly. So I am just asking you, it is a 2 marks question, tell me, and it is a MCQ. NMOS transistor fabricated in 0.3 micrometer process. This is the name of the process, right? Always remember, this is the name of the procedure. What will be the size? Where L is equal to 0.2 micrometer and W is equal to 2 micrometer. Always remember, aspect ratio will be greater than 1. So again, we are getting the aspect ratio W by L. 2 divided by 0.2, that will become 10. You can directly use W by L 10. The process technology has COX. This is called oxide capacitance. FF means femtofarad per micrometer square. Mobility is given as 450. Normally that mobility, always remember the mobility is what? In case of MOSFET, 450 centimeter square per volt second. This is the normal value, right? Threshold voltage is given. Neglect the channel length modulation, means lambda channel length modulation coefficient, it is 0. If the transistor is to operate at the edge of the saturation region, when we are talking about the edge means boundary of the saturation and triode region, with ID is equal to 100 microampere. The values required of VGS and VDS are respectively. What is the values of the VGS and what VDS? You have to calculate. Now, mainly it is what IC versus VCC graph से कैसे check करें? Which one you are saying that? You are asking about the biasing and stabilization. Okay. I will give you the idea. First of all, this one. Then remember that at the edge of the saturation, what is the ID? Half of K and S W by L VGS minus VT the whole square. Right. So it is at the boundary condition. Now, first of all, you have to calculate the K and S. What is the K and S? Mu and COX. Now, you have to change the unit of the COX 450 into what is the, this is the centimeter square per volt second. Remember, it is a 12.8 femtofarad. Femto means 10 to the power minus 15 upon micrometer square. What is the 1 micrometer is equal to 10 to the power minus 4 centimeter square of that. That will give you the value of the K and S. Everyone give me the answer. What is the value of the K and S? Once you will get the K and S, W by L it is 10. ID you have idea. What is asked then? VTN is given. ID is given. what is the value of the required VGS. Okay. From this you can get the value of the VGS, because now I am having the value of the ID. What is the value of the ID? 100 microampere. Remember, it is in microampere. Is equal to half of. When I am asking about the K and S, what is the unit of the K and S? Remember, when we are converting it into farad, or it is converted, it is what, 450 centimeter square per volt second. Then it is the current in what? It is the value, unit. Ampere per volt square. If it is the ampere per volt square, it will not work. You have to convert it into what? Microampere per volt square. So when I want to convert it into microvolt per ampere square, everyone give me the answer. What is the answer for this question? This value 450 into 12.8, right? 5760 into 10 to the power minus 15 plus 8, 10 to the power minus 7. 10 to the power minus 7. I check my calculation, everyone. Then we can write 576 into 10 raised to power minus 6 ampere per volt square. It will become 576 microampere per volt square. Okay. Now you can use this value. 100 is equal to 1 by 2 into K and S. You can check my calculation also. Then it will become 576. This is nothing but 10. What should be the value of VGS minus VT? VT is given as 0.4. So in this question, simply we have to calculate, actually we have to calculate what? K and S. K and S we have to, it is 57.6. Okay, then 57.6, check my calculation, already I have given. Okay. Calculation is your part. How to solve the question, that is important. Okay. Now from that put the value and get the value of the VGS. From this it is a very simple. Always remember the unit of this. This is the unitless quantity. This is the volt square. That is what? Ampere per volt square, milliampere per volt square, or it may be what? Microampere per volt square. First of all, check the unit, then put the value of the ID. Once you are putting the value of the ID, and when we are solving, definitely this is the right answer. You are going to get the value of the VGS, that is 0.586. And how we are going to find the value of the VDS? VDS means exactly at the boundary of the saturation. Boundary of the saturation, VDS is equal to VGS minus VT. Now, if it is 0.586 minus 0.4, it will become 0.186. This is the value of the VDS. Very simple. Easy? Okay. That is a simple MCQ, multiple choice question. Next one. You are saying that DC load line, no need to apply the DC load line, directly we can use this formula, right? You are saying that in the middle of the active region, or we can put the line, what is the slope of that line. In this way we can solve this numerical. But Now, Nidhi, right? In a biasing and stabilization, I have given you the idea about that, how to draw the line, DC load line concept. Slope of the DC load line is what? -1 by RC. And it is a fixed bias circuit. It is not a stable circuit. When we are putting the RE, it will be the stable circuit. What is the value of VGS? Yes, this is the answer. Value of the VGS is 0.586. Solve this. This is not VGS. Always you have to put the positive value. 0.586. This is the value of VGS by solving this. Now, this is the question. Next one. The transistor Q1, what is this, Nidhi? 186.7. Now, next one. Next question. The transistor Q1 has a current gain beta 1 99. For this one, beta 1 is 99. Beta 2 is what? 49. The current IB2 in milliampere. What is the value of the IB2? What is this? This is, we are giving the input to the base. We are getting output to the emitter. So this is a common collector configuration. Again, we are giving input to the base. We are getting the output from the collector. Output from the emitter. Again, it is a common collector. So it is common collector followed by common collector. If the common collector is followed by common collector, it is nothing but Darlington pair. Darlington pair. But in a gate exam, no one is going to ask you what is the name of that circuit. Simply, we have to solve the question. So Darlington pair means what? First of all, it will amplify the signal and then it will amplify the signal. So what is the IB2? IB2 is nothing but IE2. IE2. What is the IE2? 1 plus beta 2 times of what? IB2. Now this IE2 will become IB1. This IB2 will become IB1 for this transistor. Now what is the IE1? IE1 will become 1 plus beta 1 times of IB1. And we can say what is the IE1? 1 plus beta 1, 1 plus beta 2 times of what? IB2. You have to find the IB2. What is the IB2 is equal to? IB2 is equal to IE1 divided by 1 plus beta 2 into 1 plus beta 1. Very, very simple formula. Now, once it is, what is the IE1 given? 50 milliampere. What is the IB1? 99, so it will become 100. 1 plus beta 1, 49. This is the 49 and that is the 100. So it will become 50. 50, 50 cancel. 1 by 100 means what? 0.01. 0.01 milliampere is the base current. Okay, what is the another name of this circuit? For this, the current gain is very, very large. Actually, what is the current gain? This is the input current and that is the output current. This is called current gain. What is the current gain? 100 into 50. 5000 is the current gain. 5000 is the current gain. Output current is 5000 times of the input current. That's why it is called super beta transistor. What is the another name? Super beta transistor for Darlington pair. This is the Darlington pair. We are using the Darlington pair for what? High input resistance. That may be the MSQ. Next time they will ask MSQ. It is a numerical answer type question. In a numerical answer type question, we are getting the answer, but they can attach 1 or 2 line. What is the another name? Super beta transistor. Why we are using? It has very, very high input resistance. What is this? Common collector followed by common collector. What is the name of this circuit? Darlington pair. Next one. Okay, now the question on what current mirror circuit. First of all, we will solve question current mirror circuit by using the MOSFET. Then we will solve the current mirror circuit by using the BJT. Everyone tell me what is the answer. Take your time and give me the answer. In the circuit shown below, all transistors are N channel. Enhancement mode. All are N channel. This is N channel. This is N channel. That is N channel. This is N channel. MOSFET. They are identical. All are identical and are biased to operate in saturation mode. That is given in the question. All the transistors are in saturation mode. This one, that one, this is. Ignoring the channel length modulation means we have to get that lambda is equal to 0. The output voltage V out. What will be the output voltage? Okay. I think you have gone through this question. Please try to give me the answer. So which time is suitable for you? Everyone. Bootstrapping. Which one is the bootstrapping? This is not a bootstrapping. This is a simple, this is a current mirror, right? This is a identical pair that is called current mirror circuit. And in a current mirror circuit, output current is forced to equal the input current. Mirroring it, this is the, now in the circuit shown, we are having the identical transistor. We have to find a V out. 4 kilo ohm resistor is connected, 6 volt battery is connected here. 1 milliampere current is given here. And how we are going to solve this question? Very, very simple one. First of all, always watch this diagram. This is a current mirror circuit. When this is the current mirror circuit, means if this current is 1 milliampere, then definitely the current through this transistor also it will be 1 milliampere because it is a mirror of that. Now what is the gate current? Always remember gate current is 0. All the gate currents are 0 because the input resistance is almost infinite. Means what about this 1 milliampere current? This will come through 4 kilo ohm resistor. Now these two transistors are connected in series. When these two transistors are connected in series, they have both the same current. For example, if I am giving the name, like this is the MOSFET 1, MOSFET 2, MOSFET 3 and MOSFET 4. So IDS 3 is exactly equal to what? IDS 4. They have the same current and both are in what? Saturation. Because they are identical. So what is the voltage at this point? This is the VGS 4. And what is this voltage? This voltage is called VGS3. Both are identical and both are in saturation, and that's why both have the same current. That's why the VGS3 is equal to VGS4. Now what is the value of the VGS4? Watch that. What is this? 6 voltage? 6 volt. Write down the KVL. Write down the KVL from this point to this point. Highlighted portion, it is visible. Write down the KVL. When I am writing the KVL, it will become 6 is equal to 4 into 1 plus what? VGS4. What is the value of the VGS4? 6 minus 4, that is the 2 volt. Now VGS3 and VGS4 are what? 2 volt. Payas, very good evening. Payas Kumari. Now what is the answer for this one? This is the 2 volt. Now this is the 2 volt. We have to find the V out. Write down the KVL from this point to this point. When I am writing the KVL, what is the voltage at this point? 6. Subtract this voltage, you will get the V out. What is the V out? 6 minus VGS3. 6 minus 2, what is the answer? 4 volt. What is the answer for this question? 4 volt. This is 4 volt is the answer for this particular question. Okay. Now, So it is a question on current mirror circuit. Now next one, watch the circuit carefully and use the concept, and then you can get the answer. Now again, we are having the line and line. This is the BJT. Two BJTs are connected. The two transistors in the circuit of the given figure are identical. If these two transistors are identical, means again it is a current mirror circuit. This is connected. When the collector is connected to base, always the transistor will be in what? Active region. This is the voltage, same voltage. We are having the same VB because these two are connected in parallel. And that's why they have the same current. Same current. And according to current mirror circuit, the current I is, what is the I? Please read the question carefully. What is the condition for the current mirror circuit? What is the answer, everyone? What is the value of the I? It is a numerical answer type question. No negative marking. You can give the answer. We have the negative marking in what? MCQ only. Multiple choice question only. Give me the answer. What is the answer? Tell me. Now, it is a current mirror circuit. We are having the two identical transistors. It will satisfy one condition. But what is the another condition for transistor? Beta should be very, very high. Here we are having the beta only what? 25. It is a very low beta. Or for transistor, if you want to make the current mirror circuit, beta should be what? In the range of what? 1000. But the 25 is very less. When the 25 is very less, we can't use we can't say that I is equal to 20 microampere. If suppose you are giving that I is equal to 20 microampere, that answer is what? Wrong. That answer is what? Wrong. So how we have to solve this question then? First of all, what is the current mirror circuit? Watch this. This current. No doubt this 5-volt battery is connected. It doesn't matter. You have to find the I0. Sometimes it is given R here. And that battery is connected here, like this is the V reference. And this is called R reference. Then what will be the current? This point is connected here. This is a standard current mirror circuit. Let this voltage is VB. We can find V reference minus VB upon R reference. That is the value of the I reference. V reference minus VB upon what? R reference. Now, second one, since this current is divided into two parts, this is the IB, these two transistors are identical, this is the IB. And what is the current here? IC1. What is the current here? IC2. Beta equal, base currents are equal, and that's why the collector currents are also equals. IC2 is equal to I0. Now this I reference is divided into two parts. I reference is equal to what? IC1 plus 2IB. 2IB. Why 2IB? Because both the transistors are equal. This is the I reference is equal to IC1 plus 2IB. This is the current through this branch. Now, what is the IC1? Since both the transistors are equal, beta equal, base current equal, and that's why the collector currents are also equal. So we can write this is the IC2, and we can write this is the IC2 upon what? Beta. So what is the IC2 from this formula? It will become I reference upon 1 plus 2 by beta. And this IC2 is nothing but I0. So exactly that is the formula actually. I reference upon 1 plus 2 by beta. Now when beta is very, very, very large, when the beta is very large, then 2 by beta is very, very less than 1. And then we can say I0 is exactly equal to I reference. And you can directly say it. But in this question, beta is not very large. It is 30. If it is 30, you have to use the exact formula. You have to use the exact formula. So when I am going to use the exact formula in this diagram, this is nothing but this is the I, this is the I naught. And this is nothing but I reference. Directly I reference is given 20 microampere. So according to the concept of current mirror, it will become I reference divided by 1 plus 2 by beta. So what is the I reference? 20 microampere upon 1 plus 2 by 30. Everyone solve this. It will become 30 into 20 divided by 32. Right? And you will get the answer for this question. This is nothing but 600 divided by 32. 18.75 microampere. It is not exactly equal to 20 microampere. It will be less than the 20 microampere. Yes. So if in any current mirror circuit, if the beta is not too large, always use this formula. You have to use this formula. Or you can arrange this. No problem. Beta upon beta plus 2. I reference. Yes. Remember that. But every time we can't derive the formula. Na? In exam hall, if suppose we are going to derive the formula, it will take time. It will take time. Then, next one. This is again the question on current mirror. Now, this is a question on what? Voltage regulator by using BJT. Voltage regulator by using BJT. Okay. .75 microampere. No. It is a MCQ. After that, we will solve MSQ. The circuit shown in the figure, the transistor of the voltage divider circuit has beta is equal to 60. Has beta is equal to what? 60. The BJT emitter base junction has a forward bias voltage drop of 0.7 volt. This is the 0.7 volt. And VZ, Zener voltage is 12 volt. Zener diode is in breakdown, means it is a 12 volt. So you can find a V. What is the output voltage at this point? The current flowing through the Zener diode. You have to find the IZ. You have to find the IZ. Everyone try to solve this question. It is a standard circuit. It is a voltage regulator, series voltage regulator, where we are using the transistor that is connected in series with the load. This is the transistor and that is the resistor is connected series. It is in series. So it is a series voltage regulator. And what is the another? Which configuration? Everyone tell me. Common emitter, common collector or common base? What is the configuration? Common emitter, common collector or common base? Now, how to solve this question? Very simple. First of all, remember that this voltage is VB and this voltage is VZ. So what is the VE or output voltage? The output voltage is VZ minus VB. And this is called regulated voltage. VZ 12 minus 0.7, that will become 11.3 volt. Once you have the 11.3 volt, we can say IE. What is the value of the IE? Yes. Which configuration? Ravi Shankar, common collector configuration. Good. Now you can calculate the IE. What is the IE? What is the IE then? IE will become V0 by 1 kilo ohm. V0 by 1 kilo ohm, that is 11.3 milliampere. Once you have the idea about the IE, you can calculate the IB. Why we are calculating the IB? I am giving you the answer. This current is called IR because it is the R. The voltage at this point is 20 volt. Voltage at this point is 12 volt because it is a breakdown voltage, 12 volt. You can find the IR. IR is equal to IB plus IZ. So IR is equal to IB plus IZ. You have to calculate the IZ. IZ is nothing but IR minus IB. And that's why we are solving first of all IE, and then we are going to find what? IB. IE is equal to 1 plus beta times of IB. That is equal to IE. So what is the IB is equal to? IE upon 1 plus beta. What is the IE upon 1 plus beta? Beta, it is given in the question. 60 is the given in the question. When it is 60, it will become 11.3 divided by 61. Okay, this is the value of the IB milliampere. Now, what is the IR? 20 minus 12 divided by 0.2. Calculate the ohm into kilo ohm. 20 minus 12 divided by 0.2. And you will get the 8 divided by 0.2, that is the 80 divided by 240 milliampere. And what is this? 11.3 divided by 61 milliampere. So you have the value of the IR, you have the value of the IB. IR minus IB, it will give you the value of what? IZ. Calculate the IZ, everyone. Calculate the IZ. 11.3 divided by 61. 39.815 or 39.81. This is the value of IZ. Which answer is 39.8? A is the correct one. A is the correct answer for this question, 39.80. Okay, this is the case. So very, very simple one. First of all, IR, this is divided into 2 point IZ and IB. IB is IE, I is equal to 1 plus beta times of IB, and you can solve this question. Okay, A is the option. Now it is in a Nidhi, it is in a common collector configuration. How it is in a common collector? Watch this diagram. Actually, you can change the orientation of this diagram. When I am going to change the orientation, this is like this. We are taking output from the collector. This is the output from the collector, 1 kilo ohm. Sorry, emitter. This is the RE. And this is 20 volt is connected here only. Now here we are connecting the R. Or here we are connecting the Zener diode. Same diagram. Same diagram here. Base to ground, Zener diode is connected. And this R 200 ohm is connected here. This is the 20 volt. Now watch this diagram. We are taking output from the emitter. We are giving input to the base, and that's why it is a common collector. Now this is the I1, IR. This is the IZ, and that is the IB. IR is equal to IB plus IZ. The voltage at this point, once it is the breakdown, it is the 12. What is the voltage at this point? 12. Subtract 0.7, it will become 11.3 volt. That will be the question. They will give you like this. This load and transistor are connected in series, and that's why it is called series voltage regulator. This is the series voltage regulator. Because transistor and load are connected in series. Next one. Now. Again MSQ. Again what? One MSQ. Everyone try to solve this question. If alpha is equal to 0.98 and VB is equal to 0.7 volt. Alpha is equal to 0.98 and VBE is equal to 0.7 volt. The value of R1. What is the value of R1? That is the numerical. Okay. That is one numerical. Okay. No problem, Payas Kumari. Now try to solve this question. It is a MSQ, multiple. They will mention whether it is MSQ or numerical answer type or what MCQ. So multiple, select question, multiple correct option. Now, the value of R1 is 52 kilo ohm. We have to solve the numerical. Transistor is in saturation region. Directly we can say. It is a fixed bias circuit. Yes, directly we can say. And to solve the IC, again we have to solve the numerical. Okay. So for two part, we have to solve the numerical, and two part we can directly watch the diagram and we can say. Always remember, if in any diagram RE is connected, let this RE is connected. It is not a fixed bias circuit. It is always what? Self-bias circuit. RE is connected here, or collector or base, there is a two feedback. So it is not a fixed bias. This statement is wrong. This statement is wrong. Second, the transistor is in saturation region. Okay. Always remember, when the collector is connected to the base through any resistor, then there will be the current. There will be the current I that is divided into two parts. Here the current is IR1. This current is divided into two parts, base current IB, and this current will become IR2. Means there will be the current from collector to base. When there is a current from collector to base, collector is at higher potential than the base. Once the collector is at higher potential, means collector junction is reverse bias. So definitely it is not in saturation. Always remember. Because NPN transistor, in NPN transistor, if the collector is at higher potential than the base, definitely the collector junction is reverse bias. Once the collector junction is reverse bias, that will be not in saturation. So that point is also wrong. Now it is a MSQ. We have to solve. If suppose we are not able to solve in exam hall, you can directly put our A or D. It may possible that one answer may be correct. Only one may be correct, two correct, three correct, four correct. Any option. But most probably two options you can give. And then no negative marking. अब आपको attempt ही करना है तो yes, attempt it. Are you getting my point, everyone? एक बार अगर आपको you are understanding my points, then please write the yes or no. Give any comments. So without solving, if you have the idea that when the collector and base is connected, it will be in active region, that point is wrong. It is a fixed bias circuit, that is also wrong. Means now we have the two option A and D. Then I am going to give, now, yes, it may be in active region. Yes, definitely. It is not in saturation, and definitely it will be in active region. Why? Because there is a current 2 milliampere. If this IE is given as 2 milliampere, this is the IE current in this direction. If this IE current is given as 2 milliampere, means it is not in cutoff, not in saturation, not in cutoff. Definitely it will be in what? Active region. Now, if it is in active region, alpha is given. How we are going to solve this question? First, IC. In active region, IC is equal to alpha I. And what is the IE is given? This is the IE. 2 milliampere it is given in the question. Convert the resistor in kilo ohm. Let this is the 1.1 kilo ohm. So this is IE, 2 milliampere. So what is this? 0.98 into 2. So what is the answer? 1.96 milliampere. IC is equal to 1.96 milliampere. So that is also correct. This is correct. Now we have to check the value of A. We have to find the value of R1. How we can find the value of R1? Remember, this current is base current IB. That this current is IR1. This current is IR2. Let the voltage at this point with respect to ground is VB. Let this voltage is what? VC. Then, if you have the value of the VB, VC minus VB by IR1 will give the value of R1. VC minus VB divided by what? IR1. That is a VC minus VB. How we can solve? First of all, this voltage is 0.7. It is given in the numerical. So 0.7 plus drop across this resistor, 2 into 0.1, because it is a kilo ohm, 0.1 kilo ohm, milli cancel with the kilo, 2 into 0.1. So what is the value of the VB? VB will become 0.7 plus 2 into 0.1, that is nothing but 0.9 volt. One by one, everyone. One by one we can solve this. This is 0.9 volt from this point to that point. Okay. If it is 0.9 volt, what is the value of the IR2? Once you have the value of the IR2, once you have the value of the IB, you can find the value of IR1. So what is the value of the IR2? IR2 is nothing but VB divided by 20. So it will become 0.9 divided by 20, right, 045 milliampere. Please check this. 0.9 divided by 20. Now, next one, how to find the IB? Okay. IB means what? IC plus IB is equal to IE. IB plus IC is equal to IE. That is nothing but 2 milliampere. So what is the value of the IB? 2 minus IC, that is 2 minus 1.96, 0.04 milliampere. 0.04 milliampere. राइट निधि फीडबैक सर्किट में एक लेक्चर बना सकते हैं क्या? हाउ टू फाइंड द फीडबैक इन द ओके ऑन योर कमेंट्स वी विल ट्राई टू मेक वन सेशन ऑन दैट. ओके, तो IB, you have the IB, you have the IR2, then you can find the IR1. What is the IR1? IR1 is equal to you will get 0.085 milliampere. Now, to solve R1, this is not R, this is the R1 actually. VC minus VB by R1. Now we have the value of the VB 0.9. We have the value of the IR1. Now you have to find the value of VC. So what is the current here? Current is IR1 plus what? IC. If you have the value of IC, you have the value of IR1, you can find the value of the VC. So what is the value of the VC? VC is nothing but VCC minus IR1 plus IC into RC. So what is given in the question? VC is equal to 12 volt. This is the 3.3. IR1 IC, we have the idea. 12 minus IR1 0.85, IC 1.96, 3.3. Give the value of the VC, everyone. This will give you the value of the VC. Now, $5.25. Okay. Now, once you will get the value of the VC 5.25, we have all the values. 5.25 minus 0.9, already we have calculated, this is the 0.9 volt, upon IR1. What is the IR1? Addition of these two value, 0.85. Tell me, what is the value of the resistor? 5.25 minus 0.9 divided by 0.085. 51.2. 51.2. And we can say nearly equal to what? 52 kilo ohm. If this is the 52 kilo ohm, what about the first answer? Correct. First answer is the correct one. So some student will ask, sir, it is a MSQ, it will become very lengthy. No problem. But in a GATE exam, this is the question from standard textbook, that is the Millman-Halkias. If only R1 is asked, again we have to, right, to find the R1, we have to find the value of the IC. That is the part of this numerical. and these 2 points, it is a theory point. Then we can expect this type of questions as a MSQ. Okay, then now it is already we have solved questions. Okay, that is assignment for you. First assignment, I will give you the 4 question as an assignment. Try to solve this question. Here we are having the 17.8 kilo ohm, 8 kilo ohm, minus 24 volt, 1 kilo ohm, 3 kilo ohm, and this is the 2.2 kilo ohm. You have to find the value of R here. You have to find the value of R here. And this is again a MSQ. Again, the given figure is now again theoretical question. We have to solve this question only. The given figure is an example of transistor compensation for Q point stabilization. That is a theory question. Yes, it is a transistor compensation technique. In this diagram, we are using the transistor compensation technique. In a compensation technique, we are having the thermistor compensation, sensistor compensation, transistor compensation, diode compensation. So it is a question on transistor compensation. This is right. Fixed bias circuit is more stable than the cell bias circuit. This is wrong. In a fixed bias circuit, there is no negative feedback. Means that is wrong. Thermistor has the positive temperature coefficient of the conductivity. No. Or right or wrong, everyone tell me. Thermistor has positive temperature coefficient of conductivity. Right or wrong? Right. Transistors, both the transistors are in active region. Both the transistors are in active region. It is given here, Ravis. If the VCE, mod of VCE for PNP transistor, if it is greater than 0.2 volt, transistor will be in active region. Thermistor has a positive temperature coefficient of conductivity. That is right. Why? Because thermistor has a negative temperature coefficient of what? Thermistor has a negative temperature coefficient of resistivity. Means it has positive temperature coefficient of conductivity. Of resistivity. Temperature increases, resistivity decreases. Temperature increases, conductivity increases. This is the right point. Now what about this answer? You have to calculate, and that is the right answer I am giving you. This is the right answer, but you have to calculate this. Please try to calculate this answer. Okay. Everything is given. VCE1 is given, VCE2 is given, and if you want solution, or you are able to solve this question, everyone. Okay, try to solve this question. In next class, I will give the answer. Just I am giving. Always remember, you can convert the, if you unknown resistance is asked, then you can convert, right? This PNP transistor into NPN transistor. How we are going to convert? This minus will become plus. This is change the arrow. Right. Then this will become positive. What is given here? The value is given here, minus 4 and 6 volt. Then this is the first transistor. This is the 6 volt. You can change the sign of that. It will become positive, because for NPN transistor, VCE1 and VCE2 are positive. And then next one, this voltage VBE. In this question, VBE is given as 0.2 volt. You can use the 0.2 volt. It will be given in the question. That voltage is also become 0.2 volt. And use the approximation that beta is what? Very, very large. When the beta is very large, you can neglect the base current. हाँ, साहिल दोनों एक्टिव में है. Yes. Now already I have solved, and I'm going to give you the answer. Remember that, not assignment. This question is what? In active region, because always remember, If the VCE is given in the question -4 and VCE2 is given in the question -6, this is for PNP transistor. It is always negative. But if the magnitude of VCE is greater than 0.2 volt, everyone, remember that it will be in active region. It will be in active region. So from that you can get the idea. For NPN, make it positive. We are making it positive value. I am making it positive value because we are comfortable with the NPN. Now remember that this current is IC1. This current is IB1. Right? Why I am neglecting the IB1? Always remember beta is very large. You can neglect this current. IB1 plus IC1. Entering current is the, sorry, this is the IB2. This is IB2. This is the IC1. This is the IC2. What is the current here? IC2 plus IB2. Here what is the current? IB1. This current will pass IB1. What is the current here? IC2 plus IB2 plus IB1 minus IB. Everyone tell me that current distribution, if the current distribution is clear, you will be able to solve this question. Right. So first of all, remember that if you want to distribute the current, start from this. This is the IC1. This is the IB1. IB2. So what will be the current here? IC1 plus IB2. Right. This is the IC2. IB2. What is the current here? IC2 plus IB2. What is the current here? IB1. Then this current will become IC2 plus IB2 minus IB1. And then at this point, let the voltage is Vx. At this point, let the voltage is VB1. And current through this branch is IB1. And you have to find the value of the R. You can give the R is equal to Vx minus VB. Vx minus VB1 divided by what? R? Divided by IB1. Actually, you have to solve this. Right. Now, सर अगर कोई बीजेटी बाइसिंग के क्वेश्चन में आईसी पॉजिटिव आया और आईबी भी पॉजिटिव आया, यस, बीजेटी के क्वेश्चन में अगर एनपीएन ट्रांजिस्टर है, आईबी2 और आईसी2 पॉजिटिव आएगा, कन्वर्ट द पीएनपी इनटू एनपीएन फर्स्ट ऑफ ऑल. इन दिस क्वेश्चन कन्वर्ट द पीएनपी इनटू एनपीएन. इट विल बिकम वेरी इजी फॉर यू. Then change the polarity of this. This is the 6 volt and this is the 4 volt. And now what is the approximation, everyone? Always remember IC1 plus IB2, but IB2 is very, very less than IC1. You can neglect IB2 here. You can neglect the IB2 here. You can neglect the IB2 and IB1 here. But in this branch, we have to consider the IB1. So write down the KVL from this point to this point. You will get the value of IC1. Write down the KVL from this point to this point. You will get the value of the IC2. I am writing the KVL. Write down the KVL. 24 is equal to 8 IC2 plus 6 plus 1 plus 3, 4 IC2. I am neglecting all the base current because beta is very large. And what is that? From this you are going to get the IC2 is equal to 24 minus 6 divided by 12. 1.5 milliampere. This is the value of the IC2. Why we are finding the IC2? Once you have the IC2, you can find the value of the Vx. Vx is equal to IC2 into 3. That is nothing but 4.5 volt. 4.5 volt at this point. Now, from this point to this point, write down the KCL. That is the 24 is equal to 17.8 IC1 plus VC2. What is the VC1? 4 volt plus 2.2, what is the current here? Remember, this is the IB1, this is the IC1. So current here is IC1 plus IB1, but you can neglect the base current, and that's why it will become IC1 into 2.2. 2.2 into IC1. Now, when we are solving this, it will become 24 minus 17.8 plus 2.2. This is nothing but 20. 1 milliampere. This is the IC1. Once you have the value of the IC1, remember in this question VBE is given as what? We are converting the NPN into PNP into NP. VBE is given as 0.2 volt. It is given in the question. VB1 is equal to 0.2 plus drop across this. 2.2 into IC1. VBE plus IC1 into 2.2. 0.2 plus 1 into 2.2, that will become what? 2.4 volt. Now, finally, you have all the values. You have the value of the Vx, you have the value of Vb, now you have to find the value of IB1. What is the IB1? IB1 is nothing but IC1 divided by beta. And this is nothing but 1 by 100 milliampere. Now, what is the value of R? Vx minus Vb divided by IB. What is the Vx? 4.5. What is the Vb? 2.4. Divided by 1 by 100. Solve this. 210 kilo ohm is the answer for this question. Right. So 2.1, 210 kilo ohm. This is the answer, and that's why this is also correct. A is right, B is right, D is right, C is wrong. That is the multiple select question. In this type of questions, we have to use what? Approximation. Okay, you use the approximation and try to solve this question. Okay. Now, what is asked here? Sir, PNP transistor है और IB negative आया, तो IC positive आया, तो active होगा. No. We are converting the PNP into what? NPN. How the possible? If the IB is negative and IC, if the positive, then it is yes, it is in cutoff. It is in cutoff. What is the actual direction in PNP transistor? We have to change all the direction. What is the actual direction of the? If you are saying that IC, actual direction is IC, IB, and IE inside. But we are considering in opposite direction. That will be negative. That will be negative. Both should be negative. Okay, and that's why the PNP will become difficult. So we are converting it into what? NPN. The first assignment, everyone try to solve this question. That is the first assignment. And then I am going to give you the 4 assignments. Second one, if you want the PDF, then join my Telegram channel. That is the Electronics by Sanjay Rathi. This is the third one. Assignment number 4. Try to solve all these assignments and give me the answer in the comments box. Okay, hope so you enjoy the session. But what should be the suitable timing for you? It is suitable 11 to 12 p.m. daily. Late night 11 p.m. to 12. Yes, solution, I will provide you the solution, but first of all try to solve and give me the answer in my Telegram channel or in the comments box. Okay, and then I will provide you the solution. You are on BYJU'S Exam Prep. Thank you for attending the session. Subscribe our channel, like the session and share the link of this session. Okay then, thank you very much. Thank you and good night.